a previous video, I created an Arduino sketch and Microsoft Excel workbook that implemented some functions of an oscilloscope. In this video, we will test and improve its capabilities. The test circuit used in this video is based around a 555 timer operating in the astable mode. The values of the resistors R1 and R3 have been chosen to produce a duty cycle that is near 50%. Resistor R2 is a current limiting resistor to protect the LED. The main component that controls the frequency of the oscillator circuit is capacitor C2. The initial value for C2 is 470 microfarads. As the value of this capacitor is reduced, the frequency of the circuit increases. I used a value of 47 nanofarads for the other capacitor C1. It does not impact on the frequency of the square wave. Using a 470 microfarad capacitor for C2, we can see that we're getting a square wave with a frequency of about 1 Hz. Then if we swap that capacitor out for a 33 microfarad capacitor instead, then we get a frequency that's sort of closer to 16 Hz. If we swap out the capacitor for one with 3.3 microfarads, and then also delete some lines to make it a bit easier to see what we're looking at, the waveform starts to look funny. And what's going on here is that we just don't get enough samples points in the time, and we can see that if we take a look at the chart here and change its design to include the actual sample points on it. So we need to boost the sampling rate. One thing we can do is boost the baud rate up to the maximum supported by the Arduino serial monitor, so let's do that. Now we're sitting around 142 Hz, and we can kind of see a square wave, but we're still getting maybe less than 10 sample points per cycle. So we might be able to get more performance, but we're going to have to make a more radical change to the code. Looking at the difference between the end time of the last sample and the start time of the next, we can see that we're burning up time just in the serial communications. So let's restructure the code so that we do all the sampling first and then just communicate it at the end. Since we're now talking about storing the samples, and the Mega has more memory than some of the other Arduino models, I'm going to switch to an Uno. Hopefully this will mean that when the code will run on an Uno, we'll be able to run it on other Arduinos without too much drama. So here is the modified code. After a bit of experimentation, I've worked out that I can probably fit about 400 samples into the Uno's memory. Another thing I've done to save space is not bothered to record the end time of the sample, as that's not really necessary for the Excel spreadsheet to generate the chart. This section of the code just here is where we capture all of our samples, and then once that is done, we then print them out. Alright, so let's give it a test. And we have a square wave, so we are back in business. Now let's see how far we can take this with the current code. I'm just going to switch out the capacitors for something in the region of 700-ish nanofarads with the two of them in parallel. And they don't quite jump across, so I'm going to use a jumper to get back to ground here. Okay, and we're starting to get near our limit at about 720 Hertz now. After doing some online research, we've discovered that we can actually set the value of a prescaler for the analog to digital converter for the Uno using the ADCSRA register, and it recommends that we can get down to a prescaler value of 16. So here I've modified the code to set that prescaler value, and now let's give that a try and see what the impact is. And we've got a much squarer looking square wave. So let's keep testing. This test is with about 100 nanofarad capacitor. So we're measuring something in around the 4,000 to 5,000 Hertz range with no oscilloscope, which is not too bad, better than a kick in the guts.